So today we'll be connecting rate of change or the slope, remember those are the same things, and the y-intercept and the starting value. We haven't really talked about these two much. The only reason we've talked about them, and I know some of you guys caught on, but the starting value or the y-intercept is this amount. What did you need to add or subtract to get to that number right there? So we're going to talk about it and look at, if we're looking at a graph, how do I find the equation? So I went ahead and plotted the points already. Notice the scale on the y-axis is by 2, so 2, 4, 6, 8, 10, because we have to get all the way to 17. And then this way, on the x-axis, I just went by ones. Okay, so I'm going to go ahead and connect those points. Okay. So that would be the line. Now remember, we know it's a line because the rate of change is constant. When we looked at the entry task, the rate that it was changing by, even though it went 8, 4, 4, this side went 4, 2, 2. So when you actually divide them out, the rate of change is 2 for all of them. Okay, so it is a line. Now we're going to go ahead and find the rate of change or the slope from these points. So it goes from there to there. Now it's not 3 lines or 3 units or whatever. You actually have to count. So it went from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, and then 8 to 9. So it's actually went up 8 units. And it went over from 1 to 5, so it went up 4 units. Okay, we're going to do it again. Went from 9 to 10, 10 to 11, 11 to 12, 12 to 13, so that's 4 units. And then it went over 1, 2. Okay, let's do the next one. So 13 to 14, 14 to 15, 15 to 16, 16 to 17, so that's 4 units again, and then over 2 units. Okay, now this is that dumb thing that I talked about last week. I always say y's, so the change of the y, change of y, or y's over run. Okay, so change of y, so you will always want to put 8 over how much it ran or like went this direction. So rise is this way, run is this way. So 8 over 4, or it's 4 divided by 2. No matter which one you look at, 8 divided by 4 is 2, 4 divided by 2 is also 2. Okay, so probably want to write this down again. So to find rate of change or slope, you want to do rise over run or y's over run. Okay, so on our equation we had, from our entry task, it was 2, and we always multiply the rate of change by how many x's there are, so it's always 2 times x, and then in our equation we had minus 1. Now if you look at this graph, do you see where the minus 1 might come from? The only negative 1 that I see is right here, because remember it's 0, negative 2, negative 4. So this is actually negative 1. So this negative 1 is right there. It is where, and go ahead and write this, where the graph oops, let me move it up. Graph crosses the y-axis. So it's where the graph crosses the y-axis, and it's also known, or this definition is called the y-intercept. The way I always think about the y-intercept is if I'm intercepting the ball or anything like that, it's where the person catches it. So I always think of it as where the y-axis catches the line. So, and the real reason, or where this really comes from, is when you're crossing the y-axis, that's when x is equal to 0 because it hasn't moved left or right any. So it'd be 2 times 0, because when you're on the y-axis, you have a 0 value of x, and then minus 1. 2 times 0 is 0, minus 1. So it is negative 1 on the y-axis. So that is where that negative 1 comes from. Notice that's the same exact value, negative 1, that we found in our entry task. We just knew that's what I had to add or subtract to get this number. 2 times 1 is 2, minus 1 gave us 1. So that's that value right there. 2 times 5 is 10, minus 1 is 9. 2 times 7 is 14, minus 1 is 13. Okay, so that is where you get the equation. Or that's how you can find the equation looking at the graph. Now remember, I don't care if you just take points and plot the points. If you just plot the points, or take the points out of the graph and put them in a table, that doesn't matter to me. Okay? Now the other thing is if they give you an equation and they tell you to graph it. So if I gave you an equation, y equals negative 4x plus 3, and I said to graph it. Now remember that negative 4x, whatever's multiplying by the x, is always your rate or slope. And then the 3 I just told you is where it crosses the y-axis or the y-intercept. Okay, so I'm going to go ahead and graph. Okay, so my y-intercept is 3. That's always where you start. It's your starting value. It's where you start. So I'm going to go up 1, 2, 3 because I need to cross the y-axis at that number. So the y-intercept is 3, so I start at 3. Now, to find my slope from that, now it's a negative 4, so that means it needs to be going down 4. So I'm going to go 1, 2, 3, 4, and over 1. Because remember, if negative 4 is by itself, it's just negative 4 divided by 1, which is just negative 4. So anything divided by 1, that doesn't change anything. So you would go down 4 and over 1. If you just went down 4 and didn't go left or right any, it would give you a straight up and down line, which remember we can't have. So since it's a negative slope, I know that last week I drew the little skateboarder and some of you laughed at me. That's okay. So I'm going to draw my little skateboard dude. Since it's a negative slope, I'm going to make him straight up and down. So he starts at the y-intercept. And then since it's a negative slope, he has to be going down. So you would go down 4 and over 1. If you went down 4 in this direction, that would be a positive slope. Remember, it needs to be a negative slope, so you always move to the right. Okay? And then I would go down 4 more. 1, 2, 3, 4, over 1. And you just continue till you get off the graph. Then I can also go up and back because it would still be the same slope. It's just going backwards so that I can finish both directions. Okay, so that would be my graph. That would be the line of that equation. Okay, I'm going to do one more example just for anyone that might need it. You don't necessarily have to, but if I just want to show you fractions just because they always mess with people. So if I said graph y equals 2/3 x plus 4. It doesn't really matter what I pick, but okay. Oops, that was not a very straight line. Okay, again, start with your y-intercept. And I sometimes get lazy and just write y-intercept, so y-int. And then this is my slope. Remember, depending on what test you're taking, depends on what they call it. So I'm going to start with my y-intercept, 1, 2, 3, 4. And then again, remember how I was talking about rise over run, so it would be 2 is the rise, or how much I change along the y-axis, and then 3 is the run. I should have done that in blue, sorry. Okay, so I'm going to rise 2, 1, 2, go over and run 3, 1, 2, 3. Rise. Now, notice if I drew my little skateboarder, he'd have to be going uphill. Now I'm out of room, so I'm going to have to go down and back. So down 2, 1, 2, 3, down 1, 2, over 1, 2, 3. And that is my line. So that is my equation. Notice this one is less steep than this one. Like this one's steeper because my rate is a larger number. Remember, the steeper the line, whether this way steep or this way steep, the number is larger. Okay, so that is connecting the rate of change to the y-intercept. Remember, in the equation, the number multiplying times x is always your rate of change or slope. And then the number adding or subtracting at the end is where it crosses the y-axis or the starting value.